Hello everyone, Victor here. In this video, I'm going to talk about one of the more complicated type of the conics, which is hyperbola. Here, I'm showing you the typical look of a hyperbola. And as always, let's begin with a number of properties of a hyperbola. Now, first of all, we have the center of the hyperbola. So from the graph, it is somewhere here. So which is the origin. And in hyperbola, there are two vertices. One is on the right hand side, like here, and the other one is on the left hand side, like here. All right. So it has two vertices, and it has two foci, two focus points. And each of these will be at a distance from the center of C. So this one is C, and this is also of distance C. All right. Next, we have the semi-transverse axis. A transverse axis is actually an axis or a straight line passes through the foci points and the center. So here it is the x-axis, and we have a value a. This a actually is a distance from the center to the vertex of the hyperbola. So this is a. Similarly, we have another a here. Okay, from the center to the end to the other vertex of the hyperbola. Next, we have the semi-conjugate axis. It is actually the vertical axis passing through the center of the hyperbola. Right, so it is here. Now the position of the B is slightly complicated, so I'm not going to show it here, but later on you will see the relationship between A and B and C. Now here it is, the semi-focal separation C. Now notice that it is very similar to the one I've shown in the ellipse, but the main difference is instead of a squared minus b squared, here it is a squared plus b squared. So make sure that you remember the difference when you are working with hyperbola or an ellipse. Now again, we have eccentricity with the same definition as in an ellipse, but here the eccentricity, the epsilon, will be greater than 1. Again, it is like a value describing how stretched the curve, which is the hyperbola, is. And we also have directrix. Since it is symmetrical, we have two directrices as well. And again, it is there is a measurement between the center and the directrix lines, and this distance is a over epsilon, which is also equal to a squared over c. Right? If we plug back in the definition of the eccentricity. Now in a hyperbola, there is an extra property which we call the asymptotes. The asymptotes are actually two straight lines with slope plus or equals b over a, and these two asymptotes or straight lines will pass through the center. So in the graph, if I try to draw it, it will be something like this: straight line passing through the center. So this is one of the asymptotes. Oops. And the other asymptote is like this. So basically, these two asymptotes form a bounding box for the hyperbola. The hyperbola will never go through or go across these two asymptotes or straight lines. Okay, and here you see the value of b actually helps to define these asymptotes. All right. Now, as always, A, B, and C are always positive. And I'm sorry that this is not ellipse, this is actually hyperbola. One interesting thing is this hyperbola is, I always see it as a combination between an ellipse and a parabola, because it looks like a parabola, but it also have two foci points. So it's like a combination of both. Anyway, so once again, since A, B, C are just measurements of distances, so they are always positive. Now here A doesn't necessarily be greater than B, but we know that A is always less than C. That is to say, the vertex, okay, the distance between the center and the vertex is always less than the distance between the center and the foci, which is pretty obvious because the focus is always like on one side of the curve, and the vertex is like on the curve. All right. So as always, we have a general formula for the hyperbola. It is very similar to an ellipse, but then the difference is here we have the minus sign instead of the plus sign. So make sure you know the difference and remember that. Okay, and this again is taken from the textbook, and it is the simple form, assuming that the center of the hyperbola is at the origin. So from now on, we have a more generalized form which incorporates the center, and it doesn't assume that the center is at the origin. So we have x0 and y0 denoting the center of the hyperbola. Right? Now, as you can see, we have two typical forms of hyperbola. The first one is this one. Some people call it east-west opening hyperbola. Okay, and here this one will use the general formula as shown here. If somehow you know that the hyperbola is of the other form on the right, some people will call it a north-south opening hyperbola. Anyway, in this form, the equation will be slightly different. Basically, what you are going to have is you swap this y with the x. So what you have here is you have y minus y0 square. You keep the denominator, and you have x minus x0 square over b square equals to 1. Okay, so it's very similar, but you switch the x and y, the x's and the y's. All right. Now let's take a look at an example. Here in the question we have finding the equation of the hyperbola with foci s at plus or minus 5 and 2, with asymptotes x equals to plus or minus y minus 2. Now it is very typical because in the hyperbola we have two foci points, and we also have a pair of asymptotes which form the bounding box for the curve. So like the parabola and ellipse, we start with a rough sketch to know which equation that we are going to use, as we have two forms. So we have the origin here, and we first plot out the foci points. So we have the x coordinates as plus or minus 5. So let's say this is 5 and this is minus 5. All right, and we have the y coordinate, that's 2. So let's say this is 2. So we have one focus point here of the hyperbola, and the other focus point here. All right, and because of that, we know that the hyperbola will look something like this, and on the other side like that. Okay, and from then on, we know that we are going to use the first general equation, which is like this, right? Which is like this. And so how are we going to find the x0, the y0, the a square, and the b square? So let's begin with finding the center of the hyperbola, which gives us x0 and y0. So to find the center, we know that it lies in the midpoint of the two foci points, right? So from there we know that it is the x-coordinate will be the sum of the two x-coordinates of the foci points divided by 2. So therefore we have 5 minus 5 over 2. And for the y-coordinate, because it lies on the straight line passing through the two foci point, which is the transverse axis, so we have the y-coordinate as 2. So therefore we have 0 and 2, which is x0 and y0. Alright, the center. Now, so in the question it talks about, okay, so the asymptotes of this hyperbola is this one. So what we have actually here is, if I expand it a little bit, you will see that it is actually talking about two equations. The first one is x equal to y minus 2, and the second one is x equals to minus y plus 2. Alright. Now from here, you know, we can actually draw out these two asymptotes, right? A quick way to draw them out will be we find the x-intercept by putting y equals to 0. So when y is 0, x is negative 2. Okay, for the y-intercept, that is the point that cuts the y-axis. So we put x equals to y, then this one will be 2. And it has a slope 1. Alright. Now similarly, this one, the x-intercept, will be 2. Okay. The y-intercept will be 2 again, and it has a slope minus 1. Alright, so if we go back to this rough sketch, it will be roughly like, so this is 2, this is minus 2, it will be roughly like this. Passes through this, like this, and passes through this, and goes all the way here. Right? These are the asymptotes. And from the slope, right, if you go back to the first slide, the slope is actually a slope of asymptote will be equal to b over a, right? And or minus b over a, but we don't really need that. So it is a positive slope, so we pick this one. So it means that 1 equals to b over a, which tells us that a is equal to b. Alright. Now, so what next? So from here, we know that we can actually find c. Why? So remember that c is the distance between the center of the hyperbola to one of the foci point. This is c. Alright, so c equals to distance from center to focus, or one of the focus point, which is equals to the absolute value of 5 minus the x-coordinate of the center, 0, which is 5. Okay, so we have c equal to 5. Now with that, and the definition of c, we have from c equals to square root. Now remember, it is a squared plus b squared instead of minus, as in an ellipse. So we know that 5 equals to square root of a squared plus b squared. Then from this guy, we know that a equals to b, so we can just make b as a, and we have 5 equal to 2a squared, which gives us a squared equal to 25 over 2, which happens to be b squared as well, because we know that a equals to b. Alright, b squared. right? Now, so here we know A, we know B, we know x naught, we know y naught. So we have the equation of this hyperbola, which is x minus the x coordinate of the center, which is 0, square over a square. A square is 25 over 2, right? And minus y minus the y coordinate of the center, which is 2. And b squared is again 25 over 2 and equals to 1. Alright? So this is the equation of the required hyperbola. Now let's move on to a slightly more complicated example. So here in the example, the question is to find the equation of the hyperbola with foci at 1 plus or minus 2 and semi-transverse axis 1. Okay, so to begin with, again, let's plot out the rough sketch of the hyperbola. So we have the xy axis here. This is the origin. And what we have here is one of the foci is 1 and 2, right? So let's say this is 1 and we have 2 here. So what we have is one of the foci point is here. The next one is 1, negative 2. So let's say this is negative 2. We have another foci point here. Alright. So from here we know that it is the north-south version of a hyperbola. So it will be something like this. And we have something like that. Alright. So from here we know that we will be using this equation. Notice that it is slightly different from the previous one because we swap the x's and the y's. Alright. And this is not plus, this is minus. My apologies. Alright, so we are going to use this particular equation. So to begin with, as always, we want to find the center because the center will give us y naught and x naught. So what is the center? So center is, we know that the center will lie on the same line as the two foci points, right? So we know that the x coordinate of the center will be 1. And the y coordinate is actually the midpoint, the y coordinate of the midpoint of the two foci points. So we have minus 2 divided by 2, right? So therefore we have the center with the coordinate 1 and 0. Okay, so this, if I draw here, it will be somewhere here. Okay, this is the center of the hyperbola. Now the next thing is we want to try to find C. Okay, C. So once again, what is C? C is the distance from the center to the focus, okay, to one of the foci points. Right? And here we know that the center is here, 0, the focus, one of the focus point is, say, this one, the focus point is 2. So it is absolute value of 2 minus 0, which gives us 2. Right? So this is C. C equals to 2. Now we are going to find A and B. Alright? So how are we going to do that? Now in the question it tells us that the semi-transverse axis is 1. So what does that mean? Now the semi-transverse axis is actually the distance between the vertex and the center. So what it means is this gap has the distance 1. Right? So which means it is A. Right, so right away we actually know that. So if I write down, it is the semi transverse axis equals to A equals to 1. Okay, and again from the formula of C, we know that C equals to A squared plus B squared. So it tells us that 2 equals to square root of A squared, which is 1, plus B squared. Okay, and this will give us B squared equals to 3. Alright, so now we have B, or B squared, we have A, and we have X naught and Y naught. So we have everything we need. If we plug everything back in, we have the equation of the hyperbola, so which is y minus the y coordinate of the center, which is 0, and then divided by a squared is 1, and then minus, so this is x, and the x naught is the x coordinate of the center, which is 1 square, and divided by b squared, which is 3 in our case, equals to 1. So this is the equation of the hyperbola in the example. Now, if it happens that the question asks further, what are the asymptotes, or the equation of the asymptotes? So how are you going to do that? Now remember that the slope of the asymptote. Okay, so if we are going to try to find the equations of the asymptotes, we know that the slope is actually plus or minus b over a. So we have slope equal to plus or minus b over a. So b is root 3, and then it's 1. Okay, a is 1. And we know that it will pass through the center. The asymptotes will always pass through the center. So we have a point. This point is the center point, right? So what does this give us? So we remember that the asymptotes are just straight lines, and we have a point, we have a slope, we have the point slope form of the line. So if you remember how we are going to find the equation of a line, so we have y minus a point, the y coordinates of point, x minus the x coordinate of a point, equals to the slope. Right, the slope is root 3 plus or minus root 3. So if you want to write it more elegantly, you have something like this. Okay, so there you go. If you want to find the asymptotes, you just find B and A, and use the point slope form, the center, the point slope form, and then you get the answers. Alright, so here are the things that you need to know about the hyperbola. I hope this helps, and I'll see you next time.